Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome to the Ex Terra Podcast. I'm Tom Patton. Goodman Technologies is a rapidly growing nanocomposite ecosystem platform company specializing in advanced materials technology. The company focuses on advanced materials and nanocomposite technology, resulting in products that have potential applications across various industries, including aerospace, automotive, defense, energy, and electronics. My guest on this edition of the Ex Terra Podcast is Dr. Bill Goodman, founder, chief executive officer, and chief technology officer of Goodman Technologies. And Bill, thanks for joining us.
Glad to be here, Tom. Let's do this.
Let's begin with an overview then. Yeah, let's do this. Let's start with an overview of your company's mission and your vision within the space industry.
Sure. That's a good one. We're all about service here. And our mission at Goodman Technologies is to help our customers to solve their challenges. And these may be challenges that are in space, air, land, and sea. As far as our vision goes, we use systems engineering principles to work with our customers, partner with them, and we want them to be successful. That's our vision.
What really are nanocomposites? That's one of those things that, you hear that and you think you might know, but probably don't.
Well, the second part of the term composites, that's a group of different materials that come together that usually synergize to give properties that any one of the constituents by themselves don't have. But nano is where it gets interesting. So a human hair is about 100 microns in diameter. Someone with thin hair might be 50 microns. A single carbon fiber might be 10 microns in diameter. But a nanoparticle is about 1/10,000th the diameter of a human hair. And what makes them very special is if you compare their surface area to volume ratio, it's an extraordinarily high number as compared to, say, a larger particle like a marble or a baseball or a beach ball. And it's that extra energy that they have on their surface that allows amazing things to happen.
So then what are the challenges you've encountered as you've developed these advanced materials for space applications?
The challenges have been, one has to go through, a user has requirements. They're going to be really difficult. Let's take space. Let's take someone like the Missile Defense Agency.
Okay.
They have systems up there that are constantly looking at the planet, and they want to make sure that there isn't a missile launch. All right. Now the system may be sitting in low Earth orbit. In low Earth orbit, we have a radiation environment. That's one of the requirements. If we're in low Earth orbit, we're going in and out of the sunlight about 11 times a day. Okay. So you have a thermal environment that you have to deal with. In order to put things up in space affordably, you're cognizant of mass. So you'd like to have a lightweight solution. That's a requirement. And then finally, our near peers or our enemies, they might want to try and have a nuclear event to take out our satellite systems. And so therefore we have a man-made radiation requirement. So the challenge then becomes creating a material that can meet all those requirements, And then the next step of that challenge is, well, do I have a manufacturing process that can make it? And so, in the introduction, you mentioned we're an ecosystem platform company.
Hmm.
We've created an ecosystem of nanomaterials and the processes to take those materials and build them into a value-added product, like, say, a space telescope or a CubeSat.
When you, I'm still trying to wrap my head around materials that are one. I think you said 1/100th the diameter of a human hair. How, what was the process like of getting to that kind of material? I mean, you don't think about being able to do that, and yet you've obviously got some kind of a manufacturing process where you can manufacture these compounds that are basically on their own invisible to the naked eye.
Well, so nanopowders, they're about 10,000th the
Okay,
diameter of a human hair. They're really, really tiny. And but if you have a jar full of them, you can see them. And whether it's graphene or carbon nanotubes or silicon carbide or boron carbide, but one of the things that we did as we were developing products, say, how about body armor? Here's a piece of body armor right here. It's
okay,
lightweight. It's made of silicon carbide. It's designed to stop bullets. It might be used to protect future space systems from meteor impacts. So to start there, we actually created what was called a nano paste,
okay.
and that's mixing nanoparticulates into a liquid matrix, and you get a paste. So that paste becomes printable. The next thing we want to do is, kind of dry that paste out, and so that's a high temperature process since we're dealing with ceramics. And so we've created a lot of intellectual property associated with this. We have nano pastes, we have nano resins, we have nanocomposites. Um, they can all be used to make useful things. Here's another useful thing for you, Tom. This is a reusable hot structure.
Okay.
This is basically, if we look at it from this angle and imagine it's coming into the atmosphere, it's the bottom of a spacecraft re-entering.
Right.
And so we actually combined several different technologies into that product. So a very good high temperature insulation, ceramic matrix composite prepreg material, which included nano. And then finally, if we were to look at it as a cupcake, that's kind of what that one looks like. We actually have a nano paste that we frosted on there
Right.
that we did by AI empowered additive manufacturing. So,
You know, a couple of years ago, I was talking with somebody on this podcast in the graphene industry, and they talked about the kind of the discovery of graphene basically was a drawing with a pencil on a piece of paper, then putting a piece of tape on it and being able to take off that very, very fine layer of graphite to help create the graphene. Do you find that kind of a process, that discovery process, in a lot of these materials you're talking about?
um, all the time. Uh, the nano world is full of surprises. I once was working with an aerogel, and this was a silica-based aerogel.
Hmm.
And the goal was to get it down where it had a zero coefficient of thermal expansion. So the silica aerogel by itself has a slightly positive coefficient of thermal expansion. So we added a material that had a negative coefficient of thermal expansion. So as the temperature goes up, that material actually would shrink.
Okay.
And so, but what we ended up with was material that stretched even more than either of the constituent materials. And it was a little puzzling at first until you got down to, you look at an aerogel, you imagine it as a spider web.
Right.
And the other material that we were putting in there that had negative CT was a material, it was a tungstate.
Hmm.
And this material had a structure kind of like wings on a fly.
Okay.
And so as the temperature heated, these wings would rotate in, and that tungstate material would shrink. Problem is, the wings of the tungstate got caught in the spider web. And so when it tried to shrink, all it did was stretch the spider web. It showed up as a strain, and that's a way to interpret what a coefficient of thermal expansion is. So we actually made something worse. So yeah, sometimes you get surprises in the nano world.
And along those lines, Bill, how much education do you have to do with your potential clients and customers about what these materials are and what they can do?
Uh, we we have a lot of smart customers. We've had people from DARPA, people from NASA, the Space Force, the Missile Defense
Mhm.
Agency, the Office of Naval Research, and they're all really smart. So they actually, did put out topics that were looking for nano solutions. But in the course of writing a proposal to win a contract, and then actually winning the contract and having a kickoff meeting with a customer, we like to educate them and and teach them. Um, we like to show them, where the risks are in the project and the things that we're going to buy down, such that they can get to the solution that they would like to have.
Now, you've shown us a couple of examples already, but what are your primary products and services?
So you can kind of look at us as a three-legged stool. Okay.
Okay.
One of the things we offer are materials. So we have alumina, we have silicon carbide, we have boron carbide, we have nano resins, we have nano paste, we have nanophorus. Now we can use these things to make things like laminate composites, right? Various
Right.
types of composites. And we've made things like shielding, very lightweight shielding. This piece of shielding right here that makes me disappear. That's actually Zoom doing that. Everybody knows that trick. But this is only about 1.5 millimeters thick.
Hmm.
It has a density that's less than aluminum, but it provides shielding against naturally occurring and man-made radiation for things that are much, much heavier. So that's a product that's good for space systems. We enclose our space systems, the electronics in those space systems, by that shielding. It allows us to use off-the-shelf electronics. So
Okay.
that's a really big product for us. Shielding is needed for space, land, air, and sea. So we
So,
all
so
experienced the Northern Lights last year, even in Florida, where I
yeah.
am, because of a solar storm. So things like that can happen, and they're very unpredictable. So we need to be prepared for them.
So how long before they put one of those aprons made out of that stuff on me when I get a dental x-ray?
Well,
As
it's funny
opposed to
you
the
say
lead that they hang around your neck.
that, Tom, because back during COVID, uh, I have a friend. He's a chief of surgery, and he lent us an X-ray room and an X-ray technician.
Hmm.
Actually, took that panel I was just holding and brought it into an X-ray room. And the question I had for the technician was, "Hey, how many lead vests does it take to actually attenuate 100% of those X-rays?" He says, "That's a great question. I don't know the answer to it. Let's find out." So we put an X-ray reflective target on the X-ray table. We put one lead vest on it. We could see right through it. Two lead vests could see through it. Three, four, five lead vests to absorb the direct X-ray. Okay. Now, the nice thing was we did that experiment with our shielding. It
Hmm.
took one lead vest, 1.5 millimeter thick piece of shielding that I just held up to attenuate the X-ray. And so yeah, that was a really great experiment. So yeah, there is a marketplace for replacing lead in vests, in aprons, in refrigerators that store radioactive isotopes that they use in medicine, particle physics laboratories. There's lots of places where shielding can be used.
My guest is Dr. Bill Goodman, founder, chief executive officer, and chief technology officer of Goodman Technologies on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. And please consider becoming a paid subscriber. Whether you're a space professional or enthusiast, paid subscribers have the first access to premium articles and podcasts focused on the new space economy. Just visit www.xterrajsc.com and help keep the Journal of Space Commerce independent as we chronicle, cajole, and when necessary, critique the commercial space industry. Dr. Bill, without divulging any company secrets or violating NDAs, can you tell us about any of the ongoing or completed projects you've done with space-related companies?
Yeah, we recently I won't say the company names because
Okay.
they do have some NDAs, but one of the companies that does let me use a name is one called Space Copy.
Hmm.
And the young lady CEO who runs that company, her mission is to print regolith on the moon to make structures.
Okay.
And back in the back in the day, a little while ago, we actually flew some shielded regolith to the International Space Station, and we tested that as part of the Missy 14 uh, experiment. So we actually used our 3D printing, our additive manufacturing to regolith, improve upon its properties with nanomaterials so that we could extend the lives of our astronauts and space explorers on the moon. It's one example.
Tell me a little bit about your background. How did you get into all this?
Ah, gosh. I have a postcard to the right of me here. It's from 1969. It's a Dear Billy postcard. I got it from NASA. I had written to them. I'd wanted to be an astronaut, and I've kept that postcard my entire life. Next to the postcard is a glass pig with wings on it. And you've heard the expression when pigs can fly. So I
Hmm.
kind of make pigs fly. So I've been a science fiction enthusiast my entire life. Star Wars, Star Trek, all of that. But I've had things fly in space 7 times now. I paid a penny, unless you count my taxes. Government paid for these flights.
So it's not free, it's
But
included.
yeah, but hopefully one day I'll get to be that astronaut. But I've just been fascinated with space and science fiction my entire life. And I had a great job at my senior year of college. I worked at the Air Force Weapons Laboratory, Albuquerque,
Hmm.
New Mexico, working on directed energy projects for high energy lasers. When I graduated, I took a job in Los Angeles. I was the fifth person in a company there. And my colleagues all came out of Rocketdyne and Canoga Park. And
Hmm.
so when I was 21, all my mentors were actual rocket scientists. And the one who got me into materials scientists was a guy named Jack Lewis. Uh, And so I got my master's and PhD in material science and engineering at UCLA. And I composites has always been my thing. I like solving problems that no one else has been able to solve. And I like the realm of extreme environments.
Mhm.
Uh, it's kind of a niche area, so lightweight, eventually stable and survivable. And that's just what I like to do.
So then what were some of the initial hurdles you encountered when you started up your company, started up Goodman Technologies, and how did you overcome those?
Oh my gosh, this is gonna make your jaw drop, Tom. It was June of 2016. I was at church with my family. My 13-year-old son comes up to me in church and he says, Dad, my heart's doing that thing. And I put my hand on his chest
Hmm.
and it felt like his heart was going to bust through his rib cage. It was like a
Wow.
scene out of Aliens with Sigourney, Weaver.
Sigourney Weaver. Hmm.
Yeah. And anyhow, it turned out that he had a heart condition. And we went on a trip to Costa Rica, it's a third world country, he had an attack down there. There was only one pediatric cardiologist in the state of New Mexico. She didn't feel that she could do a surgery. And so we came back from Costa Rica, and I was a vice president of a company in San Diego. Um, I went down to do my bi-monthly business meeting, and on that Friday, I got laid off from my job. So here I am. I got a kid that needs heart surgery, and I don't have a job. And I interviewed with a company over the weekend, and on the Sunday, the third part of the interview, guy says, "Hey, Bill, I got these RF engineers. They need coverage in Albuquerque. What would you do?" And I said, "Well, I know this guy," and that's as far as I got in the sentence. The guy says, "I only have resources for one employee." And a little voice in my head said, "Bill, start your business."
Yeah.
So literally on Monday, I filed paperwork. By Friday, I had three customers. They were all companies that I had worked with. They wanted me to do business development. I started writing proposals. Won my first proposals in 2017 from NASA and the Army Research Laboratory. So 25 SBIRs later, 9 of those have been phase twos. In addition to that, we've had 2 phase three transitions. Um, I've been a small business person of the year. The company's been a New Mexico Technology Council award winner 4 years in a row. We It was a great time to start a business under those
Yeah.
conditions because I knew I couldn't fail. And that's the same thing that my customers have. They can't fail in their missions. So yeah, challenges. Then we had COVID. Then we had
Yeah.
rampant inflation. Then we had a change in the tax laws for research and expenditures called Section 174, which still needs to be fixed.
Hmm.
And side note, I might be one of the most resilient entrepreneurs you've ever met because I've just been kicked in the teeth a bunch of times.
And you just got to keep getting back up. But that does kind of lead me into my next question, and that is, how has the regulatory environment, particularly now with some of the new things that are going on, influenced your product development and that commercialization process?
Really the only one that is a real hurdle is for cybersecurity and the
Hmm.
CMMC that's being imposed on all businesses that have contracts with the government. We've been compliant since 2016, but it's becoming ever more difficult and ever more expensive. And I think that the problem that needs to be solved is not being compliant, but solving the problem with the cloud.
Mm.
Uh, all our information's in a cloud on a server somewhere. You and I are doing secure end-to-end communications right now, but somewhere this conversation is being recorded and is in the cloud, and anybody that is bright like a 13-year-old hacker
Yeah.
can get in and see that stuff. So, so I really think that we're misdirected in what we're looking at. So,
How do you see the competitive landscape evolving in this advanced materials sector, particularly for the space industry?
I'll tell you what. I get a lot of things in email. I look at Composites World. I look at uh, NASA. There isn't a week that goes by where something new and amazing isn't coming out. And I think this is going to dramatically accelerate as the language learning models and AI uh, exponentially mature. Um, we are living in a time where technology is just going to explode like a tsunami on a beach.
And what happens then? I suppose that's the $64 question, isn't it?
So I think the most important thing that has to happen is that we use AI ethically, and that AI is a collaborator with humans and not a replacement for humans. And that goes the same for robots. So at Goodman Technologies, we use AI-empowered additive and robotic manufacturing. We're developing the Factory 5.0, and the Factory 5.0 has the highest security available, but it also uses ethical AI. Our objective is not to replace humans, but to support humans uh, with AI and robotics to make us even more productive.
We don't want to get into an open the pod bay door house situation.
No.
Just one thing more, Bill, and tell me a little bit about the role of intellectual property in what it is that you're doing and your strategy and your success.
Well, intellectual property is something I invested in very heavily. Uh, I've probably taken about a $500,000 or more of profits and reinvested them into the company. So we have a vast intellectual property portfolio. I've actually lost count of the patents
Mm.
that we have, but I haven't lost count of the bills I get from my patent attorney every month. Um, but we've also licensed technology. Um, International has been very challenging because not only do you have to uh, defend in the United States, but now you have to defend in foreign countries.
Hmm.
Um, that system needs improvements as well. We get some patent examiners. It's like, did you actually read the other patents and see why this is different? But no, we have to take the time and the expense to answer to those examiners. And so I think that's another area where uh, large language models
Hmm.
can probably replace the patent examiners.
You never know. Let me just close with this because we do ask this of all of our guests, Bill, and that's to look out over the next 10 to 15 years in space commerce and tell me what you see.
Uh, that's an excellent and fun question. I had the privilege in 2024. I was part of the Special Operations Forces Space 2040, which looked at integrating the special operating fighters into the space domain. We even had science fiction writers there. Um, I think several of the big areas are going to be energy.
Hmm.
Space is an unlimited source for energy. Resources is going to be a big thing. Uh, you know, Even mining on our moon is going to have an amazing impact on the economy of the world, the global economy. Communications. Bandwidth is a word that everybody's probably familiar with, and the more we compute, the faster we compute, the more bandwidth we want to have. So I think energy and communications, which was the area that I supported in that 2-day workshop down here in Tampa, are going to be very high up on the commercialization of space.
Bill, we're out of time. I really appreciate you taking some time to talk with me today. Thanks so much.
Thank you, Tom. It was a pleasure to be with you, and I hope we've given your subscribers some value today.
Dr. Bill Goodman is the founder, Chief Executive Officer, and Chief Technology Officer of Goodman Technologies. And that's going to do it for this edition of the Ex Terra Podcast. Check out our YouTube channel and be sure to click on subscribe so you can stay up to date on developments in space commerce and be notified when we post new videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. Be sure to connect with us on LinkedIn, follow us on X at exterrajsc, and please consider becoming a paid subscriber to the Journal of Space Commerce. Until next time, I'm Tom Patton. Thanks for joining us.